This is the brief on the Trojan test for distinguishing moons from binary planets. So when you're looking at two objects orbiting each other, how do you know if it's a moon and a planet or a true binary system? Well, for a long time we used something called the barycenter criteria. It basically says the shared center of mass has to be inside the bigger object. But it turns out that's just an arbitrary line. It has no real physical consequence. First up, the old way just doesn't work. It's all about density, but that's not what really matters for the physics. You could have a huge but really low-density object that just happens to swallow up that shared center of gravity, and boom, you're mislabeling a clear binary pair as a simple planet and moon. It just doesn't make physical sense. Second, let's talk about the Trojan test, because this is a real, physically meaningful test. It's all based on Lagrange points. Think of them as 5 gravitational sweet spots in an orbit, where a smaller object can just hang out. Now, only 2 of these, L4 and L5, are actually stable. They're like cosmic parking garages for asteroids, like the ones tagging along with Jupiter. And finally, it all boils down to one simple thing: mass ratio. Those L4 and L5 spots are only stable if the bigger object is more than 25 times the mass of the smaller one. If the ratio is less than that, those spots are unstable. Trojan asteroids are physically impossible. That's the key. Earth is 80 times heavier than the moon, so it's a moon. But Pluto is only 8 times heavier than Charon, which makes them a binary planet system. So the Trojan test gives us a clear, physical way to classify any 2 objects orbiting in the universe as either a binary pair or a primary object with an orbiting companion.